Hey there guys, sorry for a long delay between all of the proxy videos that I was making. I've been sort of busy and I've been working on my private server, which I'm taking a little bit of break on because we're ready for beta in a couple days. So I figured I'd go through and make a quick video that I've actually made this video before and got all the way through and realized my mic wasn't attached, so it was kind of a waste. What we're going to do is I'm going to show a few different methods of reading and writing packets. So right now we're going to do a really simple example, which was packet 1009, which is an item action packet. So that's used for picking up items, dropping items. It's also used for like buying items from shops, selling to shop, unequipping items. But it's also used for things like your ping. It's just the way TQ does it. You'll notice I have a whole bunch of type 27s here. That's the ping packet. But you'll notice here if I drop the spear, I get type 3 received for this item, pick it up. It's a different packet for picking things up, so that's not going to be an issue. Drop it again, same UID, same item. It's very simple. I'm not structuring the entire packet right now because I don't care to, but I'm just going to go through how you would go about structuring a packet and how you would then write it into a packet log. So what I'm going to do here is I'm going to enable all packet logging. I'm going to drop the item, say drop, and pick it up. Now I'm going to disable packet logging, and I'm going to open my packet log. You'll notice here I have picked. That's a 1004 packet. It is the talk packet, if you ever want to structure that. There you go. We know it's a 1009 packet because you can trust me, or you can use Korvac's packet Wikipedia. You can look at existing sources. You can do it all sorts of ways here. But you'll notice there is a client to server 1B, which is actually type 27, which is a ping packet. I know this, so I'm going to ignore it. But basically, we would go to, you'll notice here we've picked up an item. This is where I dropped the item, so I'm going to delete that and say item dropped. It just helps me break up the packet and see where I'm at. Okay, so I happen to know everything above here is junk, just because I'd done a packet log earlier. So here we have a client-to-server packet, type 25, there's one here, and type 3, which I happen to know is the drop subtype. You could look at, again, existing sources, use trial and error, etc. Here we have a blank packet log. You need to know how to sort of interpret these values. Your first tool is going to be your Windows calculator. You're going to want to go into Program Review, whatever that is called. It's called something different on Vista and XP, I think. I'm on Windows 7 right now. You can go into hexadecimal mode here. And I'm going to say, first one, as I know, is always the packet length, which in this case is 0054, because they're reversed, which is packet length of 84. Now, the actual packet length will be higher than that because you have the 8-byte seal here, which says TQ server or TQ client. So plus 8, and we know that the packet length is 92. We'll need to know that when assigning new byte arrays for building our packet, but again, not super important. Again, we know that this is the packet type because it's the same in all of TQ's packets, so 03F1, again, they're reversed, packet type 1009. We know all this already. I'm just going through how you pick it up. So we have a big value here. The first thing we need to determine, is this 4 single bytes or 5 single bytes? Is it a U short, and a byte? Is it a uint and a byte, or more likely another uint? What I always use as sort of a rule of thumb is they should never be close to full. So in this case, there's no zeros in here, so it's a fairly full value. You can't fit that much more of a value in there. It's like saying 99 instead of 100. Once you go up to 3 digits, you can hold a much larger value. So here we have a 0, so it's safe to say that it's most likely a uint in this case. So we're going to say 8, 5B, 9C, 5F. That gives us this big long number. That means nothing to us. But if you look at other packet logs, you will soon find that that is the unique identification number for the item that I just dropped. You don't need to know that. It doesn't really matter. We have an unknown value here of type FF, which is 255. And then we have one here that is type 3, which again, through trial and error you can figure out what that is, but I happen to know it is the type. So very quickly we've written up a very small structure. U short length, U short type, U int, item UID, uint unknown, and a uint action. So there's our packet log. That's all we need for our structure. Everything else here is 0. We don't need to be concerned with it right now. The reason this is large is because this packet's used for a lot of other things. So if you wanted a full structure of the packet, you would have to find where these values are filled in, figure out what the packet's doing in those cases, what those values represent, and then test them. In this case, though, we know that these are our values. So we're going to go into our source here. I'm going to stop debugging, which will disconnect me from the server, which is not an issue. And we're going to create a packet structure. So in this case, I'm using a new class here, but it doesn't matter. You could write it as its own method, its own structure, whatever. I'm calling this a class just because I want to separate it and say that these are all different examples of item action packets. So I have 3 examples here. The one that most people are used to is a wrapper-based packet construction. So in this case, you have a static method where you would say, let's say I wanted to send an item action. I would say, okay, packets, okay, wrapper example. And you would fill in, okay, the item ID is 1, the action is 3, and then you could say that you just want to send this. So roll send to client or server. There you go. You would be sending this packet with an item UID 1 of a type 3 to the client. That's a very simple way of doing things, but I personally don't like it that much. The reason is as you get more and more values, you either have to write different overloads, so you would have like 5 versions of this packet, all with accepting different numbers of parameters, or have some giant long list of things that you could accept. So you'd have uint val1, uint val2, uint val3, etc., etc., etc. And every time you want to send a packet anywhere in the source, you would have to remember what these represent, where they go in the packet, and what values are valid for it, and what you want to put them to. I don't like doing that, but some people do, and this is what they're comfortable with. There's no real reason not to use it. In this case, just so you know, these read-write, the write uint 16, write uint 32, it's either using unsafe pointer logic, or it's using bit shifting, so it's saying, okay, this is what we're writing to this offset and offset plus 1. You don't need to think about that too much. If you're using this, you'll probably be using something like this that's already set up, or you'll be using pointers yourself. It's not that difficult to figure out. You could also be using a stream writer or anything. You could use a whole bunch of different methods. They're not stream writer, that's for text, but yeah. So that's our wrapper-based one. Another very common one right now, because of the prevalence of sources written by Impulse right now that have gotten leaked or sold or whatever, is using a structure to represent all of the packet, and then you actually have a private or a public, it doesn't really matter, a byte array to represent the packet. It's an actual packet stored. And then whenever you say, the instance of get set example length, you are either reading or writing to this actual packet. And then when you want to send it, you would just say sequence or send this sequence, and it would return this packet for you, so that you're not modifying it anymore, you know it's done with. In this case, I'm calling it dsequence. I don't know what he calls it. Basically, you're filling it in using a packet. So you're saying, I've received this packet, and I want to set up this get set example using the values held in this packet. You could also use a constructor here, which is, again, same as we had above. Let's say I want to create a new one with only 1 or 2 values. I can do that. Or I can create one by saying a new get set example and then assigning the values myself. Again, it's a fine system. I don't see a lot of issues with it. But the main problem I have with it is when you have really, really large class files. For example, if you're writing a private server, your entity.cs, player.cs, whatever you want to call it, will often have hundreds, if not thousands, of lines. I know Impulse's Trinity source, that's the old versions that have gotten leaked. I'm sure he's cleaned it up since. But it has something like 1,500 or 2,000 lines of code. And if you have all these maybe 20, 30, 40 different offsets that are being read and written to, you will want to be able to find all those offsets easily for debugging, testing, and updating them. Let's say TQ changes the packet structure. This is one of the methods I've been using recently, using implicit operators to build packets. So in this case, you again have a structure that's holding your values, and then you are using implicit operations to basically treat it as a byte operator or treat something else as this structure. That probably doesn't make a lot of sense to people right now, but what you would do is, in this case, I'm converting this to a pointer. I'm saying var type equals the pointer here, reading in the type. Oh, sorry. I do not want to know what I'm doing here. This is where I'm getting the pointer for the packet that I've received. So in this case, I would say packet, item action packet, implicit example, received equals pointer. Now, if I say received equals received, just so that we can sort of debug it, I'm going to do that, and I'm going to log into the game, and you'll see what happens here. Don't bother trying to hack this account, it isn't even mine, but it'd help if I knew the password. And of course TQ has their protection. So we've received a packet, and hey look, action 46, length 48, type 1009. That's cool. We've received another. Type 27, item UID, timestamp, everything's filled in right from the start. We don't need to set it, we don't need to call extra methods, it's just set. I'm going to stop debugging again. In this case, I can then say received and edit anything in there I want. I can say that the action is going to change to 3. I could say received item UID equals 1, and then I could send it. And you'll notice that this will now be treated as a byte array. That's what send to client accepts. That is because it is implicitly saying that this can be treated as a byte array. And when that happens, I use pointers to write the values that I'm holding into a new buffer. It's not the most efficient system. We could be using memory marshalling and basically how we've set up the structure of the structure, which is a little redundant there. We could be using this and memory marshalling it into a buffer and then sending it with a seal. We could be doing a whole bunch of things. But I personally like this because it keeps things simple. You don't have to keep calling different methods, and it keeps them all in one place. You can do it in any way you want. But as for actually structuring the packet, I'll go to this one because it's the most straightforward. Right here you'll see that I've set out the values I know. The ones I don't know are of course going to be 0 by default because I'm not assigning anything to them. This seal is written in my system when you actually send the packet, so that's not something we need to worry about. And this will work perfectly fine. As you noticed, it was writing out to console saying that we've received this packet. Once you've structured packets, all you really need to do is work in some simple logic saying, okay, well, I've received this item, I don't want it, so I need to drop it. Just simple logic like that. Or you could be using your spawn packets here and storing where they're spawned in relation to you and using that for all your attacking code. You could be doing a ton of things with this. But that is the most simple way of handling all your bot actions, is you're going to structure some simple packets. It doesn't matter if they have all the variables, just the ones that are pertinent to what you're trying to do. And then once you have a packet structure set out, you can worry about all the game or bot logic and go from there. Hopefully that explains packet structuring a little bit better to people. If I've missed something, please feel free to let me know, and I'll try and fit into the next unit if I ever get it done. I know there's been a big delay between this one, and seeing as my server is going public next week, it probably will be a long delay before the next one. Anyways, thanks for watching, and enjoy.